All right, this is the practice probability exam. So going over this, starting off, there are 14 boys, 16 girls in a choir. The teacher chooses one member at random. What's the probability that this is a girl? Now, as a fraction, we take a look. Now, for girls, it's going to be 16 out of the total, which is going to be added those together, which is going to be 30. And so when I take that, that's a 30. I know it's ugly, I'm sorry. So it's going to be 16 out of 30. We reduce the fraction, reduces to 8 over 15. So my answer is 8 out of 15. Now on the next one, let's see. It says the probability that Carla arrives at school before 8 o'clock is 9 out of 20. What is the probability that Carla does not? So it's not this. Does not arrive before 8 o'clock. So now, if the probability that she does is 9 out of 20, the probability that she does not will be, what's missing here is going to be 11 out of 20. And that one, it does not reduce. So 11 out of 20. So yes is 9 out of 20. No is 11 out of 20. All right. Right here for number 2, it says a bag of sweets contain 5 chocolate, 12 nougat, and 13 toffees. A sweet is selected at random. So now first, total. It says 30. So I know it's out of 30. And what's the probability that's a toffee? So my toffees are 13. 13 out of 30. And it doesn't reduce. So I will put my answer over here because I didn't do it last time. I'll do it here. So 13 out of 30. So that's the probability of it being toffee. Now for number 3. It says, what is the probability that the first guest arrives at a room? Oh, I'm sorry, here it is. A room in a hotel are numbered 1 through 22. Rooms are allocated at random as guests arrive. What is the probability that first guest arrive is given a room which is a prime number? So 1 is not a prime number. So the first thing I'm going to do, I'm going to list out prime numbers. So 1 is not a prime number. Prime numbers could only be divided by 1 and itself. So my first one's going to be 2. Because I only could divide that by 2 and 1, so that's prime. 3 is prime. 5 is prime. Let me see. 6 is not, because I can multiply that. I can get 2 times 3 is 6. 7 is prime. Not 9, not 10, 11. Okay, not 12, 13. Not 14, not 15, not 16, 17, not 18, 19, not 20, not 21, or not 22. So these are list all the prime numbers in between 1 and 22. So those are my prime numbers. Now, what's the probability that the first guest arrived given a room in which is a prime number? So let's see. We have how many rooms? We have 22 rooms. And let's see, 1, 2, 3, 4, 5, 6, 7, 8. There's 8 total out of 22, which will reduce to 4 out of 11. Now, let's take a look on B. All right, before I get too far into this one, I need to go over how to reduce it in the calculator. So I have my calculator here. So on these calculators, the number was 8 out of 22. So I'm going to go 8, and to reduce, you would go Control, Divide. That gives me my fraction, which is 22. 8 out of 22, hit Enter. It gives me 4 out of 11. Now, if you would have did the other way, you would go 8 divided by 22, hit Enter. This one's automatically set up as a fraction, but if it didn't give you a fraction and gave you a decimal, you would go Menu, Number, and then you would convert to a fraction, which is 2 also. and just hit enter. And that gives you your 4 out of 11. And it's the same thing for all the other ones too. So whenever you're actually trying to convert it to a fraction, you do it like that. Now, let's go back to number B. So the first guest to arrive is given a room in which is a prime number. So the probability that the second guest to arrive, which is a prime number. So now, the first one's prime. Okay, so that means that we have one less prime room. So instead of having 8 prime numbers, we're going to have 7 prime numbers. But now, that person also took over a room. Since we have 22 rooms, we're going to have one less room. So it's going to be 7 out of 21, which reduces to 1 over 3. Let's see, do it right here. Go 7 out of 21. Enter, gives me 1/3. All right, for number 4, it says 2 students are selected at random from a group of 15 boys, 13 girls. Find the probability that they are both girls. So the first one, this is without replacement. So for them to be girls, it would be 13 over, now add them together. I have 28. So that's the first one. Now the second one, now if I'm taking out a girl, that means there's going to be one less girl because I chose a girl already. So that would be 12. And if I already chose one, that means my total has to go down also out of 27. So now here, I'm going to do the math on the calculator. We have 13 divided by 28 times, and
are you doing cross product?
No, I'm not. I'm multiplying. This one's not coming out right.
Oh, that's multiple. Is that a little dot right there? Oh, that's what I meant. I thought this.
So 13 over 28, so it's times my answer times my 12 divided by 27. Enter, and kind of does it wonky. I don't know why it does it like this, but it always wants to do this. I don't know why. But my answer is 13 out of 63. Okay, all right, now on this next one, that one is a boy and one is a girl. So now my first thing I'm going to do, set up my fraction for one of them being a boy. So boy is going to be 15 out of 28 times the girl, which is going to be 13 over 27, because I took out a boy, so that means it's one less to the total. I'm not changing the number of girls, so I don't change that number there. So that's why it's 15 and then 13. And go ahead, enter that in the calculator. So 15 over 28 times 13 over 27. So again, it does a weird thing as it sets up here. So we have 65 over 252. All right, this next one, 5A. It says, bowl of fruit contains 5 apples, 6 bananas, 3 pears, 1 orange. Whatever the name is, chooses 1 piece of fruit at random. What's the probability that she chooses a banana? That means that there's 6 bananas, and the total, so that's going to give me 11, 14, 15 out of 15. So 6 out of 15, I have to reduce that. And I get 2 over 5. Okay, now mango. Now this is the one that's probably going to be tricky for most people. How many mangoes do we have? There's no mangoes. 0 mangoes out of 15. This stumped most people in the class for like 15 minutes. Like, there's no mangoes. You're right. We represent that in math with 0. So probability, 0. All right, number 6. A bag contains 8 green, 6 yellow balls. Sandy takes 3 balls out of the bag without replacement. Find the probability that all 3 balls he chooses are yellow. So the first one is going to be 6 out of the total, which I need to add those together. I get 14. Now, the probability for the second time. So the first one chosen was a yellow. So that means that there's going to be 1 less yellow. So that's 5. And since I took 1 out, that's going to be out of 13 now. And for the next one, I'm going to do another yellow. So I have to take away another yellow. So that's 4 out of 12. So each time I was taking away 1 yellow. So that affects that. So let's see. Let's see how wonky this one turns out to be. 6 divided by 14 times 5 divided by 13 times 4 divided by 12. I get 5 out of 91. All right, number 7. You're choosing a password that must have 3 letters followed by 3 digits. So 3 letters and 3 digits. So there are possibilities for each. Now, for the first 3 letters, I have to go through and how many letters are there in the alphabet. There's 26, 26, 26. So there's my first. And so I can repeat. So that's important. Okay, can be repeated. So I could repeat the same letter over and over again. Now, followed by 3 digits. There are 10 digits, 0 through 9. So to figure out my answer, I have to multiply those together. So I'm going to have 26 times 26 times 26 times 10 times 10 times 10. So my answer comes out to be 1757600. 3 zeros. There's 17 million possibilities for this. All right, for number 8, says for summer reading, you're asked to read 3 books from a list of 8. How many different groups of books can be chosen? Now, since it doesn't matter if we pick it first or last, okay, it's any group, okay? So, 3 books from a list of 8. So that means that this is going to be a combination. So it's going to be N, C, R, and there's going to be 8 total, and I'm only going to pick 3 of them. The reason why it's combination is it doesn't matter if I read Grapes of Wrath first or if I read it last. If I still have to read it, that's part of the combination. So order doesn't matter here. So right there we have NCR. So right here, menu, probability, permutations, and it is 8, 3, and we get 336. Now, for this next one, how many permutations are possible of that many letters? Now, let's see, how many are there? 1, 2, 3, 4, 5. Now, this is basic. This is basic permutations here. So as for all of it, it's going to be 5, and then factorial. So if I'm doing it by hand, it's 5 times 4 times 3 times 2 times 1. So I'm just going to do the factorial. So it's 5 factorial hit enter, and I get 120. Now for number 10, it says 10 horses are running a race. How many different ways that can these horses come in first, second, and third? Now, first, second, and third. That's important because that means it's a permutation. Order does matter. So there are 10 horses, so it's going to be NPR, 10 horses. And how many places do we have? We have 3 places. So menu, probability, permutation, is going to be 10, comma, 3, close, enter. There's 720 different possibilities. All right, 11, geometric probability. So from the formula right here, it is the shaded area over the total area. So the shaded area is going to be this. It's a rectangle, so it's 4 times 3 over this rectangle, which is the whole thing, which is going to be 8 times 5. So it's 12 out of 40, which will reduce by 4, which is going to give me 3 over 10. 3 over 10 is my geometric probability of hitting that little spot. All right, number 12, what is the probability of throwing a dart into the shaded area of the circle? Probability of throwing a dart into the shaded area of the circle on the dartboard. So now, I got to figure out the area of this first, which is just the shaded, so it's going to be, if 2 from all the way across, that means that the radius is going to be 1. Same for this, okay? If this is 10 going all the way across, from here going all the way down, the radius is going to be 5. So now for the top, it's going to be pi, my radius is 1 squared, pi r squared, and that's going to be my shaded part, over my total, which is going to be pi times 5 squared. So in my calculator, okay, in my calculator, I'm going to go with, so pi I'm going to parentheses this. So pi times 1 squared. There's my pi r squared. And I'm going to go divided by. The parentheses are important here is because I'm going to do all the top and then all the bottom. So I'm going to parentheses the bottom too. So right there we're going to have pi times 5 squared. Close that parentheses. So now I have all the top. So all the top here. Have all the top. So it's going to look like this. So top divided by the bottom. Hit enter. And it's going to give me 0.04. 0.04. So I'm going to fraction that. So I'm going to menu, number, and I'm going to turn it to a fraction. Hit enter, and I get 1 out of 25. So 1 out of 25 probable chance to hit that.